are the constellations of the solar system because of a visit from a foreign star. According to recent research, a stellar guest flew so close to our home system billions of years ago that it altered the paths of thousands and thousands of small celestial bodies. It's possible that some of these bodies were ripped from their trans-Neptunian orbits and flung into the interior of the Sol system, where they were eventually captured as moons by the large gas giants. Venus, Earth, and Mars, Jupiter, Saturn. The Uranus, Neptune, yes. But when we think of our solar system, we often assume that it ends at the outermost known planet, which is Neptune. However, astronomical reality shows that this is not the case because far beyond Neptune's orbit, there are two equally remote and extensive areas, the Kuiper Belt and the Oort Cloud, that are thought to be the comet's places of origin. Suzanne. Fair from the Jülich Research Center is aware that this is by no means a sparse collection of cosmic debris. In fact, thousands of these trans-Neptunian objects have been discovered, but occasionally knowledge is linked to a higher-level mystery. As a result, the eccentric orbits of these objects, which are inclined relative to the planetary plane, have long been a mystery. Fortunately, we now have the technology to solve the unsolved mysteries of our time digitally. Specifically, Fer and her colleagues from the University of Leiden in the Netherlands carried out more than 3,000 computer simulations to uncover the cause of the unusual orbits and to find out whether the strange orbital characteristics of the trans-Neptunian objects could be traced back to the influence of another star, and they were successful. The bottom line for the astrophysicist was that a single close flyby by a stellar visitor is indeed capable of explaining the strangely inclined and eccentric orbits of the trans-Neptunian celestial bodies. This even applies to those objects that are, to put it mildly, far away, such as the dwarf planet Sedna discovered in 2003, which on its journey through space comes within 1,000 astronomical units of the Sun. Just to recap, 1 astronomical unit is the average distance between the Sun and the Earth, or around 150 million kilometers, and the background of those objects that move on orbits almost perpendicular to the planetary orbits can also be plausibly explained with the help of a Clos-CL star passage. However, the same applies to the celestial bodies 2008 KV-42 and 2011 KT-19, which made astronomical headlines after their discovery because they move in the opposite direction to the planets closer to the Sun than Voyager. But how exactly did the star passage happen billions of years ago? And what did the corresponding celestial body look like? Well, in this regard, Fer states that the nature of the present-day outer solar system can best be explained by the flyby of a star with a mass of about 0.8 solar masses. Furthermore, the simulation showed that the star passed at an angle of about 70 degrees to the planetary plane and at a distance from the Sun of about 16.5 billion kilometers, or to put it another way, the radiant stranger was closer to the Sun than the 2 Voyager probes are now. In fact, Voyager 1 and 2 have now moved up to 2465 and 2061 billion kilometers away from our host star, and as is well known, they are currently exploring the mysterious world of interstellar space. This fact is even more remarkable when we consider that the twin probes, which are identical in construction, actually only set out into space in 1977 to study the outer members of our planetary system. And while they were doing this, they were also supposed to add numerous new moons to the star charts in the realms of the gas planets, and we now know that Jupiter, Saturn, and company are sometimes accompanied by moons that could not be stranger. Basically, experts assume that our Earth's moon and many other moons were formed together with their planets. For this reason, they also orbit their planetary fixed points prograde, which means nothing other than that they follow the direction of rotation of their planet. However, this does not apply to all natural satellite light, as Jupiter and Saturn are accompanied by a strikingly large number of moons that behave irregularly and orbit their planets retrograde, or in other words, backwards, if you like. And while this usually also occurs in highly inclined elliptical orbits, the rotational pattern there is firmly in retrograde hands in the case of Jupiter. Astronomers count a total of 71 satellites that move in the opposite direction to the planet's rotation, and only 16 prograde moons for Saturn. The retrograde prograde distribution is even 100 to 22, and for Uranus and Neptune the proportion of irregular. Satellite significantly exceeds that of regular ones. But how can this be explained? How is it that we find so many moons here that differ so much from the expected pattern? Well, quite simply, the researchers suspect that the retrograde moons did not see the cosmic light of day together with their planets, but were captured by them only later in detail. It is conceivable that the original home of these special companions is in the Kuiper Belt. Conversely, however, this also means that something must have caused the celestial bodies to lose their status as trans-Neptunian objects and become moons instead. But what the arrival of the moons? Well, some time ago, the answer to this question would probably have been through the migration of Jupiter and the other outer planets. Accordingly, Jupiter in particular may once have milled through the early solar system like a planetary wrecking ball, thoroughly stirring up the existing structure. But unsurprisingly, Suzanne Fer also points to the stellar visit hypothesis. In the case of the retrograde moons, on the one hand, it's in the nature of things that a celestial body with 0.8 solar masses would have set off enormous gravitational turbulence, and on the other hand, this assumption also coincides with the results of the computer simulations. In principle, the stellar chaos may have catapulted most objects in the outer region of the solar system even further outwards, or even completely out of our homeworld. And yet the model also showed that 7.2% of the trans-Neptunian objects were catapulted inwards. In detail, we are talking here about up to 10 million objects of 100 kilometers in size, or up to 10,000 objects larger than 1,000 kilometers, and the bottom line is that it's possible that some of these objects were gravitationally captured by the mighty gas planets and captured as moons. This hypothesis also coincides with the retrograde-prograde distribution mentioned above. In the Jupiter region, the trans-Neptunian objects were about 30 times more likely to end up in a retrograde orbit than in a prograde orbit at Saturn. It was around 20%, and although the majority of the new satellites were later ejected from their orbits, enough settled moons remain to explain the existence of the irregular satellites today. How a star robbed the young solar system. As we can see, the big questions about the solar system don't necessarily require numerous complicated answers, and according to the researchers, the real fascination of the star visit model lies precisely in its simplicity. After all, it's able to solve a whole series of cosmic mysteries with just a single cause in detail. However, this stellar passage is by no means the only one that Suzanne Fer has already studied, as she and her team discovered a few years ago. There is also evidence that the young solar system once narrowly escaped a catastrophe and was significantly altered in the process more than 4 billion years ago. A star with a M mass between 0.5 and 1 solar masses is thought to have passed through the outer edge of the solar nebula. Although thousands of celestial bodies have already been identified, astronomical models actually suggest that many more objects should be lurking. The blazing bright celestial body is believed to have approached our young sun to within 100 astronomical units, which is roughly 3 times the distance between Neptune and the sun. As the star passed the edge of the 150 astronomical units, large solar Oort Cloud, it tore some of the material there with it, ultimately explaining many peculiarities of today's outer solar system. Beyond Neptune in this regard, Fellner and his colleagues even assumed that the mass of the Kuiper Belt region was reduced to around 1% of its original mass as a result of the flyby. Furthermore, the star passage not only explains the eccentric orbits and the inclination of many trans-Neptunian objects against the planetary plane, but also the mass ratio of Neptune and Uranus, as well as the existence of 2 separate populations of celestial bodies in the Kuiper Belt, according to the researchers. Model calculations. The probability of such a close stellar flyby is 20 to 30%, and apparently just one celestial body is enough to explain the characteristics of the solar system, from strange orbits to retrograde and prograde moons. And while we have discussed the terms prograde and retrograde in detail today, diggrade has unfortunately been somewhat neglected. But if you've just had fun with our video, you should definitely click on the like and the subscribe button. Now please become a part of our community to stay up to date from now on. See you soon.